Hi students, today we are going to see the topic about types of steels. Myself, host Sathish, Assistant Professor Mechanical Department at Akshya College of Engineering and Technology. Steels are alloys of iron and steels are alloys of iron and carbon. However, steel contain other elements like silica, manganese, sulfur, phosphor, nickel, etc. The alloying elements are either intentionally added or retained during the refining process. In general, plain carbons classifications having three types: low carbon steel, medium carbon steel, and high carbon steel. Low carbon steel or steels are relatively soft and weak. They cannot be hardened appreciably by heat treatment, but it can be strengthened by cold working. They possess good formability and weldability. Plain carbon steels are those in which carbon is the alloying element that essentially controls the properties of alloys and in which the amount of manganese cannot exceed 1.65% and the copper and silicon content each must be less than 0.6%. This plain carbon steel having different names. Other names are carbon steel, non-alloy steel, and straight carbon steels. Few applications of low carbon steels as an image which is shown here. Mostly it is used as a sheet, strip, bar, plates, tubes, pipe, wires. This plain carbon steels having used for mass production products such as automobiles and applications. They also find applications in the production of ball bearing, base plate, housings, clutches, structural members, etc. The low carbon steel represents the largest tonnage of all the steel product. The low carbon steels are those steels that contains less than about 0.25% carbon. The low carbon steel, also known as mild steel. Typical applications of low carbon steel include automobile body components, structural shapes, I-beams, channels and angle iron, and sheets that are used in pipeline, building, bridges and tin cans, etc. Medium carbon steel. They have high strength and hardness properties with the absence of ductility and toughness. This image shows the medium carbon steel at 200 micrometer. Medium carbon steels are those steels that have between 0.25 to 0.60% carbon content. The medium carbon steels may be heat treated by austenizing, quenching and then tempering to improve their mechanical properties. The typical application of medium carbon steels include railway wheel, railway track, gears, crankshaft and other machine parts. The plain medium carbon steels have low hardenability. Plain medium carbon steels have high strength and hardness properties. Because of this, the crankshaft machine parts and all, we are using medium carbon steels. High carbon steel, they are least ductile, more brittle of the carbon steel. They have more wear resistant. They are capable of holding a sharp cutting edge. It is the important property of making tools. These high carbon steels are those steels that have more than 0.6 percentage carbon content. Typical applications of plain high carbon steel including cutting tools and dies, forming and shaping materials, knives, razors, haksha blades, springs, and high strength wires. Alloy steels. Any steel other than the carbon steel is called alloy steel. Alloying elements chromium, nickel, molybdenum, vanadium, tungsten, cobalt, boron, copper, and other etc. Classification of alloying steel: low alloy steel and high alloy steel. Low alloy steel, this contains up to 3 to 4% of alloying element. They have a similar microstructure and requires similar heat treatment to that of a plain carbon steel. Low alloy steels are the steels which contains up to 3 to 4% of one or more alloying element. They have similar microstructures and requires similar heat treatment that of plain carbon steels. They are also referred as perlitic alloy steel, as the normalized structure contains the eutectoid perlite. Classification of low alloy steel: AISN steel, HSLA steel. AISN American Iron and Steel Institute steels are the steels that are generally used in machine constructions. AISI steels are sometimes also referred as constructional steels or structural steels. AISI steels normally have less than about 5% total addition of elements such as chromium, nickel, copper, molybdenum, manganese, vanadium, etc. The property of the major interest in the AISI steel group is hardenability. High alloy steel. High alloy steel is a HSLA steel, also known as microalloyed steel. They have different microstructures and requires heat treatment that they can be a plain carbon steel. Classification of high alloy steel: tool and die steel, stainless steel. Tool steel are high quality alloy used for tools, dies, etc., which require special characteristics of hardenability, wear resistant, resistant to softening on heating, and other likes. But in stainless steels are used to improve corrosion resistance. Here in the table column we can see the elements. Before seeing that, we will see effects of alloying element. The alloying element in steel affects the stability of this phase, the relative amount of the phase, and how the phase are disturbed or dispensed throughout one another. Thus, the alloying element affects and controls the properties of steel. The alloying elements such as nickel, manganese, copper, cobalt tend to stabilize austenite. The alloying elements such as chromium, vanadium, manganese, silicon tends to stabilize ferrite. Some alloying elements such as chromium, tungsten, teak, molybdenum, niobium, manganese tends to form carbides. Other elements such as silicon, cobalt, aluminum, nickel tends to destabilize carbides and form graphites. Now we see these elements which gives aluminum effects of element. Strong deoxidizer forms nitrides and fine grains. Chromium ferrite stabilizer raises tensile strength, fatigue strength, hardness and wear resistant. Cobalt prevent grain growth, retains hardness and strength at high temperature, also improves thermal conductivity. Copper raises yield point. Manganese carbide stabilizer improves strength, hardness and hardenability, eliminates evil effects of sulfur. Molybdenum enhances resistance to creep and minimizes temperature embezzlement, also increases resistance to corrosion of chromium steels. Nickel austenitic stabilizer acts as a graftonizing and increasing basic strength. Niobium forms stabilizer carbides, enhances high temperature strength and creep resistant. Silicon stabilizes and hardens ferrite, improves resistance to corrosion. Titanium forms hardened and stabilized carbide, stabilized stainless steels and raises strength. Wolframite stabilizer carbides improves strength and hardness and also enhances cuttings of power of tools. Vanadium refined grains and stabilizes ferrites, most of them of the same effects of wolframite. Because of these elements, the steels gets different types of properties. The properties of all steels or of all alloys are determined by the kind and amount of phases of which they are composed, by the property of the phases and by the way in which these phases are distributed among one another. That's all for today's session, students. Thanks for listening. Thank you.